Welcome back to electrochemistry. Moving to the questions directly. First question, magnesium, aluminum, sodium, calcium, they are arranged in the order of their potential, electrode potential. See, it is strictly from NCERT, there is a heading called electrochemical series. It is also in first year, redox reaction. So from that list you have to arrange the elements. It is not possible to by heart all the values of the electrode potential, but you can create some order. See, an order. This is from NCERT. Lithium, potassium, calcium, sodium, magnesium, aluminum, zinc, iron, nickel, hydrogen for a reference. Copper, hydrogen potential is 0 and all these elements have negative potential. These elements have positive potential. So look at this order and you answer yourself. Okay, I am leaving to you. Question number 2, possible reaction at anode. Anode, oxidation happens. Cathode, reduction happens. In terms of electron, oxidation is losing electron, and in terms of electron, reduction is gaining electron. So find the reaction with the losing electron. Okay, it's easy. Standard potential for a cell, Seren bar Seren 2 plus double vertical line Cu 2 plus bar Cu. Concentrations are also given, but for finding the standard potential, no need of concentration. Okay, respectively the standard E0 of zinc half cell and copper half cell, that is also given. See, for a cell there is a formula, standard potential E0 cell is equal to E0 cathode minus E0 anode. Cathode is copper, positive 0.34, minus of minus 0.76. That means adding 0.34 plus 0.76, 1.1 volt. Answer is okay. Question number 4, which of the following is the strongest reducing agent? See, I am leaving that answer also to you. Strongest reducing agent. See, in this particular series also, lithium is a powerful reducing agent because its potential is minus 3.05, reduction potential. So reducing agents powerful means its reduction potential is the lowest or having high negative value. Fluorine is the last element of electrochemical series. Its potential is 2.87, positive 2.87. So that is a powerful oxidizing agent, all of you know. So reduction potential highest indicate powerful oxidizing agent, lowest indicate powerful reducing agent. See, all these reactions are given as reduction. You just find the answer, that's all. I am leaving to you. Question number 5, voltaic cell, salt bridge. It's an easy idea. Salt bridge, when anode and cathode are connected externally, okay, cell reaction happens and there is a chance for creating positive charge at anode solution, okay, and a negative charge on cathode solution. So that will create a liquid junction potential. So to minimize the liquid junction potential, we are introducing a salt bridge. Okay, it will maintain the neutrality. Okay, do not allow mixing solution but maintaining the neutrality. That is the main purpose of salt bridge. Answer is the keeping the solution electrically neutral. Okay, you know salt bridge, inverted U-shaped glass tube filled with some inert salt along with agar, gelatin, etc. Okay, it will provide proper ions into both of the solution, anode and cathode, to neutralize its charge. Question number 6, anode reaction in mercury cell. See, it's anode means oxidation, mercury anode, zinc amalgam, zinc and mercury, and that is capturing OH from the electrolyte KOH to form zinc oxide, water, mercury and electron, releasing electron. Option is there, find it, anode reaction. Okay, exactly given in NCERT, nothing more. Next also, next 2 questions. 7th question, reaction occurring at anode during the discharge of lead storage battery. Anode soft lead and that is capturing sulfate to form PbSO4 for releasing electron. Okay, find it. Question number 8, hydrogen oxygen fuel cell, the reaction occurring at a cathode. Cathode means through anode we are passing hydrogen and through cathode we are passing oxygen, and reduction happens for oxygen forming OH group. O2 receive electron and water to form OH is the reaction happening at cathode, and that is also you can find. So question number 6, 7, 8 strictly from NCERT. Everything is from NCERT, but ditto copy is asking. Question number 9, when a solution of electrolyte is heated, conductance increases simply because the main reason ions acquire more and more kinetic energy. So it is able to break the surrounding attraction and moving forward. That is the reason. Anyway, we can find the answer by checking each and every option. Increases mainly due to the increase in the number of molecules of the electrolyte. There is no chance of increasing the number of molecules. Decrease because not decrease, it is increasing. Okay, conductivity increases. Third option is also decreases. Never. When temperature increases, conductivity increases. And fourth option increases because electrolytes dissociate more. Probably that is one of the accepted reasons. Agree. Maximum chance is for option 4. The real reason is kinetic energy increases. Okay. Question number 10. Solubility S of a sparingly soluble salt. Specific conductance K, small k. Molar conductance lambda m are related. See, solubility is sometimes called as molar solubility. It is often expressed in mole per liter. So instead of molarity, we can write S, that's all. And of course, you know what is lambda m. The formula for lambda m. Lambda m is equal to K into 1000 by molarity, and instead of molarity, you can write solubility S. So this is the equation, and rearrange this equation and find the option. Rearrange this equation and find the option. Okay. This is the equation, and you can change in any pattern, no problem. Okay, every expression is connected to S. So bring S here and lambda m to the right side, that's all. Next one. The resistance of 0.01 molar NaCl, 200 ohm. R is given, concentration is also given. Cell constant is given as 1 centimeter raised to minus 1, molar conductance. So lambda, I am changing this solubility as m. And K, of course, you know, K is equal to 1 by R into cell constant. So I am substituting lambda m is equal to K, 1 by R value, 1 by 200. 1 by R into cell constant, K value, cell constant 1, into 1000 divided by the molarity, value of molarity 0.01, 10 raised to minus 2. So find and tell me the answer. That is question number 11. Moving to question number 12, limiting molar conductance of NaCl, HCl, CS3, COA, Na at infinite dilutions. 3 values respectively given, and molar conductance of acetic acid. It's a direct application of Kohlrausch's law. You know, acetic acid lambda m 0 or lambda m infinity is measured by adding the lambda m 0 values of CS3, COA, Na and HCl and subtracting the lambda m 0 of NaCl. Normally, in all classes, this is the particular example we are discussing. Lambda m 0, CH3 COOH is equal to lambda m 0 CS3 CONA plus lambda m 0 HCl minus lambda m 0 NaCl. So, respectively the values lambda m 0 CS3 CONA is 91. So, 91 plus HCl value it is 426 and minus NaCl value is 126. Solve it and find. Okay. Question number 13. On passing C ampere electricity through an electrolyte for T second, m gram of the metal get deposited at cathode. Equivalent weight of the metal. See, what is the meaning equivalent weight? Equivalent weight I will tell you an example, and after discussing the example we have to generalize it. See, when we are electrolyzing copper salt, Cu2 plus. This is the reaction normally happens. Cu2 plus 2 electron gives Cu. That means 2 moles of electron deposit 1 mole of copper from Cu2 plus. Charge of 2 mole of electron is 2 Faraday. And the weight of 1 mole of copper 63.5 gram. So 2 Faraday can deposit 63.5. So 1 Faraday can deposit 63.5 divided by 2 gram, and that is called equivalent weight. So equivalent weight is defined as the amount of the substance deposited by 1 Faraday. 1 Faraday means 96500 coulomb. So amount of the substance deposited by 96500 coulomb is called equivalent weight. If it is for 1 coulomb, then 63.5 by 2 into 96500, that is called electrochemical equivalent. Weight deposited by 1 coulomb is called electrochemical equivalent. 96500 coulomb is called equivalent weight. There is a drastic difference between these two terms. So here the equivalent weight is asked. This one is asked, and there is a connection. They are passing C ampere current for t second. See, there is a formula Q is equal to IT. I is the current strength in ampere and T is the time in second. Time is T in second, but I is they are giving as C. So CT coulomb can deposit m gram. CT coulomb can deposit m gram. So 1 coulomb can deposit m by CT gram. 1 coulomb can deposit m by CT gram. I told you how many coulomb? 96500 coulomb can deposit how much, and that is called equivalent weight. So equivalent weight, answer is the equivalent weight is equal to m by CT into 96500 gram. This is equivalent weight. Okay, question number 14. Yes, equivalent weight is m into 96500 divided by CT. Option is the third option. Agree. Question number 14. I think this is clear. Okay. Moving to question number 14. M gram of electricity passed through an electrode. When quantity of electricity passed 1 Faraday, then mass deposited at a electrode is equal to 1 Faraday can deposit. What is the name of the weight? I told you 1 Faraday 96500. That is called equivalent weight. Equivalent weight is also called 1 gram equivalent. Equivalent weight can also be named as 1 gram equivalent. It is not electrochemical equivalent. Electrochemical equivalent is the weight deposited by 1 coulomb, not 1 Faraday. 15. Question number 15. Mass of copper deposited from copper sulfate by passing 5 ampere current for 965 second is. We can do the question in 2 or 3 pattern. I am sticking on the previously discussed pattern. Otherwise, there is a direct formula. Okay, according to Faraday's first law, weight of the substance deposited is directly proportional to Q. Weight of the substance deposited or evolved is directly proportional to the quantity of the electricity passed through it. So W is equal to ZIT. Okay, Z can be changed as Z is equal to M divided by NF into IT. M is the gram atomic mass, N is its valency, and F 96500. So using this formula, we can find W is equal to M 63.5 into I. How much is passed? 5 ampere into T. 965 second. You can easily cancel it. Okay, Cu SO for Cu2 plus, so valency 2 into 96500. So by solving this, you can find the answer. That is the weight. Otherwise, I will tell you one more method. See, Cu2 plus 2 electron gives Cu. That is the equation we have seen. And 2 into 96500 coulomb can deposit 63.5 gram. So 1 coulomb can deposit how much? 63.5 divided by 2 into 96500 gram. Agree. And in the question using this formula, Q is equal to 5 into 965 coulomb. Okay. So this is for 1 coulomb, how much deposited? Therefore, this much coulomb. Answer, weight deposited is equal to 63.5 divided by 2 into 96500 into 5 into 965. The same thing. Okay, so using the stoichiometric calculation, otherwise you can use the direct formula. You can find the answer. I am not giving the last answer. You find yourself mathematical calculation and tell me in the group. Question number 16. Current in a given wire is 1.8 ampere. Number of coulomb that flow in 1.36 minutes. Okay, coulomb is Q. Q is equal to IT. And Q is equal to IT. There is a condition. I is current strength in ampere and T is the time of flow in second. But in the question they have given the answer of time in minutes. So convert into second by multiplying with the 60. That's all. Okay, it's an easy question. See, Q is equal to, again, I current strength I 1.8 ampere into time is 1.36 and 60. Why we are multiplying with the 60? The time is in minutes, but here ampere second is coulomb. Ampere second, so it should be, time should be in second. Find and tell me. Question number 17. What is the reduction potential for the half cell at 25 degrees centigrade? Al3 plus 3 electron gives Al. Al3 plus concentration is given as 1 molar, sorry 0.1 molar. E0 value is also given. So direct application of Nernst equation. You know, for a half cell, Nernst equation is equal to E is equal to E0 minus temperature 298. So 0.0591 by N into log concentration of the products divided by concentration of the reactants. Agree? At a temperature 298 Kelvin, we can use the value 0.059 or 0.06. Sufficient. Nernst equation, I think everybody know. I am going to give the substitution. E0 value they are given as minus 1.66 minus 0.0591 by 3. N value is 3. Al3 plus 3 electron. And aluminum is the aluminum product, that is solid, and Al3 plus, that is the reactant. See, concentration of solid is normally taken as 1. So this become minus 1.66 minus 0.0, I am giving it as 6 by 3 into log 1 divided by Al3 plus concentration, that is given as 0.1 molar means 10 raised to minus 1. So when we are bringing this 10 raised to minus 1 to the numerator, become 10 and this become positive. Agree? Do the last step of calculation yourself. I am not doing it. This is 0.1, 10 raised to minus 1. When we are bringing to the numerator, become 10 raised to 1. 10. Log 10 is 1. So this term is vanished. Only 0.06 by 3. Minus of, okay, this 10 raised to minus 1 become positive. Solve it. That's all. Question number 18. Calculate the potential in volt for a voltaic or galvanic cell indicated. GA bar GA 3 plus 10 raised to minus 6 molar double vertical line, AG plus 10 raised to minus 4 molar bar AG. E0 values of the respective half cells are given. Anode gallium, cathode silver, and you are asked to find the potential of the cell. So application of Nernst equation again, but it is for the complete cell. This equation is for a half cell. Now the present question connected to a complete cell. What is the cell potential? E cell is equal to E0 cell minus 0.06 by N into log concentration of the products by concentration of the reactants. Now let us write the cell reaction. What is the product and what are the reactants? Let us see. Anode gallium. So gallium 3 plus. So gives Ga 3 plus 3 electron. That is anode reaction. And cathode silver, since there are 3 electrons, we have to take 3 Ag plus 3 electron gives 3 Ag. So the net cell reaction is Ga solid plus 3 Ag plus aqueous gives Ga 3 plus aqueous plus 3 Ag solid. See, concentration of solids we are not counting. Why? Because we are assuming it as 1 and we are counting only the ionic species. So the product is Ga3 plus and reactant is Ag plus cube is there. Agree? And also we have to find this E0 cell. E0 cell is E0 cathode minus E0 anode. Cathode 0.8, anode minus 0.56. So E0 cell is equal to 0.8 minus of minus 0.8 minus of minus 0.56. 0.56. So minus of minus become positive. Okay, so that is answer. So 0.56 plus 0.80, 6, 1.36. Agree. So positive 1.36 is the value of E0 cell. So 1.36 minus 0.06 by 3 into log concentration of the product gallium 3 plus. Its concentration is given as 10 to the power minus 6. divided by concentration of the reactant Ag plus. Ag plus concentration is 10 raised to minus 4, but its cube is the 12. So 1.36 minus 0.02 log 10 to the power minus 6 divided by 10 raised to minus 12. And when I am bringing this minus 12 to numerator, become positive 12. So it become 10 raised to 6 positive. So that 6 become, okay, 6 log. So answer 1.36 minus 0.02 into, okay, 6 log 10 means 6. Log 10 is 1. Okay, multiply and solve with the 1.36. That will be the right answer. Okay, calculation, the last step I am leaving to you. So a simple application of Nernst equation. That's all. Question number 19. Okay, after giving the cell, how to write the cell reaction. Okay, and we are avoiding the solid material, we are counting the ionic species, etc. These are incorporated. Okay, question number 19, corrosion of iron involved. The last area of the chapter, corrosion. Fe become Fe2 plus, O2 become water, and Fe, yeah, they are giving anode reaction, cathode reaction, overall reaction. Everything is correct. Question number 20, hydrogen oxygen fuel cell 1.12 liter of H2 at STP consumes maximum electricity produced. Hydrogen at anode oxidation happens. Okay, let us calculate. See, whatever may be the reaction, anode losing electron. This is the net change happened at anode because we are taking hydrogen at anode. 1.12 liter of H2 consumes at anode. What is the maximum electricity produced? See, 1 mole of H2 at STP means 22.4 liter, and that produces 2 Faraday. 2 Faraday means 2 into 96500 coulomb. So this is the normal relation. 22.4 liters of hydrogen when completely consumed at anode, 2 into 96500 coulomb electricity generates. Now what is the volume? 1.12 liter. Okay, so what is 2.24 liter? Answer 2 into 9650 coulomb. 10 is vanished. Then 1.12 liter means just a half, means 9650 coulomb. That is answer. 9650 coulomb. By 2, the 2 get cancelled. Clear? So these are the questions from electrochemistry. So study well. So this was a missing chapter. After completing solid state, I directly entered to chemical kinetics. Now solution, after solution I entered to chemical kinetics. Actually I forgot to take electrochemistry. Actually it is already recorded, but I don't know where it is. Okay, so that's all. Study well. Once again, this is the last laps of run. Okay, in every race, not the initial push or the work during the, in between the final stage and the initial stage. Okay, they are not deciding the result. Okay, the result actually that is decided by the last lap of run. Okay, so you are in the same situation. So last lap, try harder. Okay, maximum effort. It will make some fruitful results. Agree. And one more suggestion for you. Due to this pandemic situation, you are actually have some precautions while entering the examination hall. You have to wear the glove, mask, sanitizer, everything. Okay, when we are using the glove, okay, it is difficult to bubble. Okay, in OMR sheet you have to be very careful. Okay, so while marking the OMR and using the glove, it is difficult for the students. That was the experience from my hostel students. Okay, so in your home, you try yourself, you wear a glove and bubble. Make it as a practice. Okay, do it 2 or 3 times. Then only you enter to the examination hall. Otherwise it will become difficult. Okay, when we are committing a slight mistake in the OMR sheet, that will be rejected. Okay, so be careful, and that is one thing. And another point, normally I am advising the students in the same way, attend the most easy area of the question. Most probably most of the students have biology as the easy area. Okay, so attend biology. If a student like physics, no problem, go to physics. But most of the students, from their opinion, I realized that biology is the easiest area. So attempt biology questions, not all questions. At a glance, you know, there are so many easy questions, mark it. Okay, whenever you got the answer, immediately that transfer to the OMR sheet. Don't hesitate. Don't wait to the last lap of the examination. Okay, after finding all the answers, you are filling the OMR. That is not a good habit. Okay, immediately you mark the answer and using a scale and the marker. Agree? Corresponding question number, don't make it a mistake. Okay. So after biology, go to the next subject, maybe physics or maybe chemistry. Most of the students like chemistry. Okay, and finally to the physics. Agree? And in the initial step, find the easiest one. And after bubbling the easiest answer, then go to the medium type question, and then only the last difficult type question. Remember one thing, this year examination is not to be very hard. Okay, it's a medium question paper, just like the KEAM examination. So be confident. Okay, be confident. Okay, you have done a lot of work, and you are the luckiest group of students because you have got so many time for the revision. Okay, May 6 was the target, but April, okay, May, then June, July, August, now it is September. That means around 4 months you have got. Okay, so I think you have made a fruitful work behind it. So result will be the, okay, pray to God. Okay, then nothing, that's all. Okay, so all the rest for a good future.